Okay, can you guys hear me?
Yeah.
No, you can't hear me?
Yeah.
Okay.
Big loud.
Okay, I gotta think really quick. I'm not ready for this. Okay, so, wait, okay. So my passion project is engineering, right? Um, um, a lot of people did like why I'm passionate about this. To be honest, I don't know why I'm passionate about it. I just know that I am. Like you guys see that, right? While I was working on that, I was with my godfather who he works in like tech stuff. He has friends who are engineers. And he was watching me do this and he said that like in all the time he's known me, like in all of my life, when I was working on that, that was like the most excited about something that he's ever seen me. And that he really knew that I was going to be like really happy about the outcome. He knew I was passionate about it. And I know that like with other things that I've done like this, people have said things like that. So yeah, I know I'm passionate about this, but to be honest, I don't really know why. Because to some of you guys, it might be kind of boring. Like, well, the topic of engineering might be boring. Like, I know you guys thought that was cool. When I brought it in, you guys were like all excited. But yeah. So what is engineering? Engineering is the application of science and math to like solving real world problems. Like if somebody's like, I'm hot, like how could you use math and science to solve that, like to make you not hot anymore? Like heat wise, yeah. Or like if you're too cold, how could you fix that? Um, wait, okay, so why is it important? Engineering is actually like extremely important. Pretty much like everything that you guys like take for granted wouldn't be here without like the help from some type of engineer. So like the AC, a heater, your fridge, like to keep your food from getting bad, your phones, pretty much everything. These speakers, this mic, like everything. The projector, the computer, yeah. Okay, so the first type of engineering I'm going to talk about is mechanical engineering. Mechanical engineering is pretty much like, so the mechanical engineer they work on like power producing machines, so like motors, generators, stuff like that. But they also do like power like using machines, so like a fridge, an air conditioning unit, stuff like that. So this is a motor. It says Bugatti. This would be made by like a team of mechanical engineers, and yeah. So this guy, he's Cisco Ramon. He's from The Flash. He's a mechanical engineer. In the show, he makes like all the Flash's stuff. He makes his suit. He makes the gun that Captain Cold uses, which would be a power using machine. So yeah, all of that. And then a mechanical engineer in real life, like I bet you guys couldn't really think of one just off the top of your head, but Joe. Bill Nye, he's actually a mechanical engineer. I mean, of course he didn't choose a career in mechanical engineering. He chose to be the science guy, but yeah. So next is electronics engineering. Electronics engineering would be, like, that's more for doing like stuff like electronics. So like the stuff that goes into a computer that actually makes it work, like the stuff that goes into your phone, all of that. So like stuff like that, like the computer board, all the chips and everything, yeah. Like continuing with the whole superhero theme or whatever, this is Scott Lang, he's Ant-Man. He is a electronics engineer, which he would need to be with everything that he has, like all this stuff. And then an electronics engineer in real life is Steve Wozniak. He built the first Apple computer, like before Steve Jobs even got like involved with the company. And then for Apple II, which was their second computer, he designed and built all of the like computer stuff, while Steve Jobs just worked on like the outside, the whole box thing. And yeah, so mechatronics engineering is a combination of those two, plus like a ton of other types of engineering, like systems engineering, computer engineering, all of that. And that's the kind of stuff, or this is like what really goes into like stuff like robotics, like stuff like this. This is Asimo, it's a robot, something like that. It's a combination of like all these types of engineering that you need to actually do cool stuff. And one type of engineering by itself doesn't really do anything exciting. It's kind of boring. Like if you just had like a motherboard just in your hand, like because it would just be boring. But working with like a ton of other engineers, they're able to do all this stuff. That's pretty much what mechatronics engineering is this combination of all those different types of engineering that let you do super awesome stuff like this. So like on the topic of robots, what is a robot? You guys probably, like when you think of a robot, you think of like Osimo or like Wall-E. But like when you Google the definition of a robot, it's a machine capable of carrying out a complex series of actions automatically, especially when programmable by a computer. So pretty much like anything that can do something like by itself is a robot, and it doesn't have to look cool. It pretty much just does like things you need it to do, things you might not be able to do, things that are dangerous for you to do. So this is an industrial robot that works in a foundry. Now, a foundry is where like they do all the metal casting and stuff, and it's a pretty dangerous job. Like you can get hurt. So using robots in jobs like these would eliminate that risk of like getting humans hurt, and would also like make it so humans don't have to waste their time like making the metal when they could be using the metal to like do stuff, like cool stuff. Like what? Okay. Yeah. So why is this stuff important? For all the reasons I just said, like making it so we don't have to get hurt doing these, I guess, like mundane tasks, when we could be like using our time to do stuff like that's much better. That's like, yeah. Okay. So next. Now my little robotic arm thing. It's not a robot because it's not like programmable. Well, it is programmable, but it isn't programmed. It doesn't do stuff like automatically, but it is robotic because robotic is like of or relating to robots, and that's pretty much what it is. And it's an arm thing, and it's not that big. So next. So this is pretty much the process of me making it. I put it all on Snapchat. So the first thing I had to do was build the gearboxes, which if you look at it are the yellow like things in the arm. Now gearboxes, what they are is it's just that it's a box with gears in it. Now it has a motor. The motors are connected to the wires that are sticking out. And the motors, when they get powered on, turn the gears and they actually make the thing move. And there are 5 gearboxes, one for like every part of it. So for the shoulder, for the elbow, for the wrist, and for the hand itself. Next. So huge batteries. This thing does take a lot of power. It doesn't move that fast, but it does take a lot of power. Those are 4D batteries, and those are in the thing. Next. So this is after I pretty much built like the whole arm. This is before I built the hand, and this is before the batteries actually powered anything. So there was the hand. The hand is pretty small, but it took so long to build. It took like that thing took like I don't know, like half an hour to an hour to build, because there are so many things that went into it, and it's just so intricate. And like there's a ton of screws in there. So that was the thing pretty much when it was all built, but it still couldn't do anything because it didn't have like all the whole like computer thing that it needs to actually do stuff. So there's the board. You have to, okay, so there were like wires sticking out of the battery thing, and those, you have to plug them into the board because the board tells the batteries pretty much when to power what. So after that, like, you can't really see it, but like in the middle are all these pins. They're called GPIO pins. I forgot what GPIO stands for. It's something input output. But later I would plug in all the other wires into that, which that later went under the yellow thing so the board can't get hurt. But so the wires get plugged into that, and then the board would later tell pretty much the batteries when to power, like when to send power to what wire, which controls a certain part of the robotic arm thing. So next I had to build the controller, which the controller pretty much is just a board with open circuits in a little plastic container. There are little metal pieces that get pushed every time you move one of the things, like one of the joystick things, which closes the circuit, and that then tells the board, because you plug the controller into the board, that tells the board which motor to send power to, and like, yeah. So once you like let go of the circuit, is then open. It doesn't actually work then. So that was it after I finished. Now, since there aren't too many of you guys can come up, and I'm going to like show you guys how this thing works and stuff. So yeah. So I have to plug in this thing into here so it'll actually do stuff. This is a ribbon wire, I know that, but yeah. So if you want to put the solar circuit works, you can. It could, well, no, it probably wouldn't. So, oh, I can't. And then we'll give him to Scott. I'm going to give him to Scott. We'll give him to Scott. So, it's slow, yeah. There you go. But yeah, so that's my arm. And it's pretty cool. No, that's my other arm. Yeah. Okay, so it can hold, I think, like, yeah, around 2 or 3 pounds. It can't hold anything super heavy. And also, it doesn't have a super strong grip strength. So, like, if you put your finger in there, it wouldn't hurt you. It would just watch it go. Okay, so it makes these clicking sounds because that's like as far as it'll go. And it's trying to push harder, but it can't because it's not that strong. So it just pretty much prevents you from hurting yourself. Yeah. So any other questions about this? Oh yeah, this thing took 3.5 hours to build. Like, yeah, it took a while because there's a lot of like very small parts that you have to put together. It can, it's 15 inches. Like when it's fully extended, it's 15 inches tall. Yeah, there's a lot of controls because there are 5 motors. One motor is here, this is the shoulder. This is the elbow. No, this is the elbow. This is pretty much, this is the wrist, this is the arm. And then, yeah, this I guess would be the shoulder together. Okay. Oh, wait. Okay, so yeah, these have letters and numbers. M1 means motor 1, which is in here. M2 is here. M3, M4, and M5 is in there, which I can take that out and it's right there. Yeah. Oh, and also, once you open this thing, it has a light. So, yeah.
So you can work in the dark?
Yeah, so you can work in the
No
dark.
way.
Yeah, of course, you can't get that far from it because this thing doesn't go that far, right? But I did originally want to like make it, I wanted to put it on wheels and I wanted to make it wireless, but that is so hard. Like, programming is extremely difficult. I haven't really learned how to program. You have to program with Python. I don't really know how to use Python. I can use JavaScript, but that's just like to make games and stuff. But yeah, so pretty much for weeks I've been trying to program this thing, but it's extremely difficult. And yeah, but I do have I bought it on Amazon for like $30, but I did build it.
Is that it?
Okay, my second hour, listen up. We have homework. Check the homework on my website.